So here's another topic which is due very soon, and I wanted to do one with you. All right, so predicting the relative forward and reverse reactions. No, thank you. Predicting relative forward and reverse rates of reaction in dynamic equilibrium. I got a lot of people here at the house, so pardon me. All right, so really what I got to do, let's talk about what dynamic equilibrium is. Let's come over here and let's look at this, okay? So at equilibrium, equilibrium means, this is if something is at equilibrium, what it means is that the amounts of the product and the reactant, the ratio of the amounts of the products and reactants is constant. It's constant at a particular temperature. Okay, so if it's at equilibrium and the amount of products is increased, well, the number of reactants is going to have to increase as well. All right, and at equilibrium also means that reactants are making products at the same rate that products are making reactants. And these two statements are equivalent. The fact that the ratio of the amounts is constant. Pardon me for the background noise here. Let me get that door shut. That the ratio of the products and reactants is constant, and it means that the rate of the forward reaction and the backward reaction is the same. That's what equilibrium means. Okay, so let's go back over here now, and let's read the question. Okay, so suppose that we've got, imagine that we've got N2 and water are added to an empty flask. Okay, so if it's an empty flask, that means it looks something like this. Right? Just a flask. I mean, I put it around bottom flask, whatever. Okay, there's nothing in there. Okay, but when we do that, or rather to an empty flask, we add N2 and H2O. Okay, so we come over here, and it looks like those are the reactants, or rather the products. Okay, so if we're adding the products to an empty flask, that means that we're going to have some of the backwards reaction. It's the blue reaction, but none of the forward, because we had no ammonia or oxygen in there. So, ready for the question now. That means we're only going to be getting the backward reaction right now. Let's keep that blue, I guess. We're only going to be getting the backwards reaction because we had 0 of the beginning stuff, and we had N2 and water, right? And you can't take 0 and make N2, right? Let's go back over here. Now, if we had this many moles, 131 and 393, whatever that means, okay, what is the rate of the reverse reaction before any N2 or H2O is added to the flask? Well, it's going to have to be 0, right? Because if it's empty before we add anything, then it's going to have to be 0, right? Because if we have 0 and 0, right, we can't have any forward reaction because we don't have anything going, and we can't have any backwards reaction because we don't have anything going, right? So let's get rid of that. All right, that's why it's 0. Now, what's the rate of the reverse reaction just after N2 and H2O has been added to the flask? Well, we've already set ourselves up for that. The rate of the backwards reaction is something, right? It's positive. And the rate of the forward reaction is nothing because there's nothing there. So it's going to be greater than 0 and greater than the forward reaction because there is no forward reaction, right? What is the rate of the reverse reaction at equilibrium? Okay, this is at equilibrium. Now, since it's at equilibrium, it's going to be greater than 0 and equal to the rate of the forward reaction, right? Because that's what equilibrium means. Equilibrium means that the rates are equal. Okay, how much N2 is in the flask at equilibrium? Well, if we started out with 131, let's get this in red. Right, if we start out with 131 moles, then some of it's going to go to the reactants, right? But not all of it, because we're going to have some of both at equilibrium, okay? So how much is it going to be there? Some, but less than 131 millimoles. All right, so that's the reasoning for that. I want to emphasize that when you, let's click solve. I want to emphasize that when you do these, oh crud, daggone it. I'm supposed to hit check. Okay. Well, anyways. Anyways, all right. So I think you get the point. What we're doing here is we're setting up the reaction. Each one of these instances, go ahead and set the reaction up and find out what's going on. If it's already at equilibrium in the beginning, then you're going to have some forward and backwards reaction. But if you got nothing in there, it's going to be 0. All right, and hopefully that's helpful. There's a lot here to this very, very abstract concept. So let me know if you want more on this. And good luck to you.